In this video, we will cover the last part of alkene, which is unsaturation test for alkene. Unsaturation test for alkene is used to detect the presence of carbon-carbon double bond and also to distinguish between alkene and alkene. We have two tests of alkene. The first one is a bromine test and the second one is Bayes test. For bromine test, the reagent and condition used is bromine in dichloromethane, whereas for Bayes test, the reagent used is KMnO4 OH- cold. The first test used to differentiate alkene and alkene that you can use is bromine test. Alkenes do not react with bromine or chlorine in the absence of light because alkene is saturated hydrocarbon. It is already stable. So alkene will only react with bromine and also chlorine in the presence of light to produce either bromoalkenes or chloroalkenes. Without light in the dark, there will be no reaction. So the observation shows that the bromine color, the reddish brown color of bromine, remain unchanged. Example 1, I have propane, which is saturated hydrocarbon, react with bromine in the dark. There will be no reaction. So the color of bromine, reddish brown color of bromine, remain unchanged. But when I expose bromine under the sunlight, the reddish brown color of bromine disappeared because reaction of propane and bromine will produce bromopropane. Unlike alkene, alkene is unsaturated hydrocarbon. Alkene is a reactive compound which can react with bromine in the dark to produce dibromoalkenes. With or without the presence of UV, alkenes still will form dibromoalkenes. The reddish brown color of bromine will disappear. Example 2 shows propene react with bromine in the presence of UV and also without the presence of UV in the dark to produce the same product, which is 1,2-dibromopropane. This shows that alkene is reactive hydrocarbon. The photo shows that reaction of alkenes with bromine turns the reddish brown color of bromine to colorless. Second test to differentiate between alkene and alkene is Bayes test by using coal basic potassium manganate. Alkene will be oxidized to form diol, and brown precipitate is observed due to the presence of manganese oxide. Purple color of potassium manganate will turn to colorless if the reaction is positive. For example, propene react with coal basic potassium manganate will produce 1,2-propane diol with the presence of brown precipitate manganese oxide. Purple color of potassium manganate decolorized. For cyclohexene, reaction of cyclohexene with potassium manganate, coal basic, will produce 1,2-cyclohexane diol. Purple color of potassium manganate will be decolorized and manganese oxide observed. Reactions of alkenes with coal basic potassium manganate is negative. Purple color of potassium manganate remain unchanged. The photo shows when alkene is added with coal basic potassium manganate. The observation shows that purple color of potassium manganate become colorless, and manganese oxide, which is brown precipitate, observed.